Good morning, everyone, and welcome to this session. So today we'll be talking about cost-effective data management with S3 batch operations and the S3 storage classes. Am I coming through all right on the audio? Everyone looking good? Great. Thanks for joining me this morning. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'm excited to go through this session with you. We'll have a lot of information here about a couple of our new product launches and how they fit into the overall S3 portfolio. And we'll also have a demo that we walk through. So for S3 batch operations, you'll see a console view, and we'll walk through it step by step. So recapping some of that, talking at a high level about the pillars of cost optimization. We want to kind of highlight some of the different considerations you might go through when you're thinking about how to use storage in Amazon S3. Then we'll talk about how to place your data, so how to use the different storage classes. We use things like lifecycle management and then storage class analysis together and see how you could do that manually yourself. But then we'll move ahead to intelligent tiering, which is our new storage class, where it automatically moves from a frequent tier to an infrequent tier. So that will help you get the cost savings, but it automates that work for you. So you just put the data in that storage class, and then it'll move over time, and we'll talk about exactly how that works. Then we'll go through some different examples. So we get a lot of questions from customers about, like, here's roughly the workload I'm working with, the size of the objects, here's how they're accessed. What's the right storage class for me? We've got a few examples we'll walk through, and we can talk through some of the considerations and some of the decisions you might, some of the considerations that might help you make that decision. And then last, we'll go to S3 batch operations. So we'll talk about the feature overall. This is a feature that's really about convenience and simplicity. So whenever you have that moment where somebody says, we really need to go back and encrypt all our data, and you have hundreds of millions of objects, and you say, how do I even get started? I don't want my development team to shift over to a tool just for that one-time work. You can just take a list of those objects, hand it to S3 batch operations, and do work like that in an automated fashion. So that's a way to get started and get up and running with that. And then the demo will show you step by step how it's really simple to get started in the console, and then that'll map easily over to the SDK's API CLI if you're doing it that way. So we'll start first with the pillars of cost optimization. This is a few different factors that we'll talk about when you're starting to think about how should I use storage in the cloud. And I think this will be applicable whether you already have storage in Amazon S3 or whether you're looking at it as something that might be in the future or something on the horizon for you. So first, you want to think about application requirements, and you want to say, how is this data going to be accessed and used? Something like log files, where it might be likely that within the first 30 days, someone might go back and ask questions or do some analysis. But after that, it's really just held onto for retention and compliance purposes, where you hold onto it for another 5 years, 10 years, whatever the right number is for you. That gives you a lot of information about how you might want to use our storage classes or about what might be the right kind of savings that you could get from moving that to Glacier over time. The next one is thinking about data organization. And this will come into play in a few different places. So if you want to put all your data in one bucket, there are benefits to that, and that's going to help you decide, OK, well, now I need to think about the policies and how I might be able to treat data differently within that bucket. We also have customers that when you're designing new workloads and new applications, if you do things like put the data in different prefixes or apply different object tags, that can also help you design different policies that are specific to that type of data. So the data organization, you'll see filters come up a few times about prefixes and object tags. Then right sizing takes some information from the application requirements and then helps you make decisions about how much data should be in S3 standard, how much should be in maybe the infrequent access storage classes, and then is there a long tail and is most of the data moving to Glacier over time? So that's something that the initial information you might go through when you think about the application requirements will drive that decision later on about how to use the different storage classes. And then lastly, and you'll see this come up again when we talk about lifecycle policies and storage class analysis, there's that first step where you start saying, how is this application going to behave? What's going to be the certain uptick of a particular feature among my customer base? But then you might find that your initial assumptions don't exactly match with reality, and you're seeing different patterns and different usage patterns over time. So you want to decide, like, is that worth it for you to go back and change what you might be doing with lifecycle policies, change what storage class you're using? Or is that something where intelligent tiering might be a better fit because you've just offloaded that work, and then this monitor, optimize, repeat never really comes to mind because you can see that automated savings by using intelligent tiering storage class. So skipping ahead here. Customers choose Amazon S3 for a number of different reasons. This slide really highlights the benefits of Amazon S3 overall. A few of them we'll really highlight today are that manageability, and that'll come into play for storage class analysis, lifecycle policies, and S3 batch operations. And then when we talk about the storage classes and look at the overall storage portfolio, you'll see things like availability and durability and how they differ across the different storage classes. The scalability of S3 is something where you can grow to petabytes or exabytes of scale. So you do have the flexibility to start growing on S3 and really scale over time. And then on security, really is the focus of other talks, but it is absolutely the focus of giving you the controls you need to control security at the account level with something like block public access, and at the bucket level with the same feature, or doing things like controlling access at the object level with object access control lists, or doing that with IAM policies as well. So you have all the flexibility to design the security and access control requirements that your business needs. So now I want to introduce you to the overall S3 storage class kind of portfolio. And depending on when you've last looked at S3, there are some new additions to this. So intelligent tiering is a new storage class announced at reInvent. And then Glacier Deep Archive launched as generally available earlier this year. So that helped us to expand our portfolio and really gives you that many more choices when you say, what's the right storage class for me? And we'll talk about a lot of these when we talk about the different workloads later on. At a high level, S3 standard is really for kind of a general purpose storage class. So it's for frequently accessed data. It's about 2 cents a month, and it's really going to meet your needs. There's no retrieval fees, no object size requirements. So a lot of customers find themselves starting with S3 standard and saying, when I learn more over time, then I'll take advantage of the other storage classes as well. In the middle of this slide, you see standard infrequent access and one zone infrequent access. So as the name implies, they're really designed for infrequently accessed storage. But you're going to see later on, it still has millisecond access. Your end user's not going to see any performance difference. And then as long as that data is being accessed about 1 time or less per month, you're probably going to see savings by using these infrequent access storage classes. So if your data is only really being frequently accessed for the first month, you really want to think about how you can use infrequent access after that to still get the performance you need, but to save on the cost. And then as we move to the right on this slide, you see Glacier and then Glacier Deep Archive. Glacier and Glacier Deep Archive give you the cost savings you need, especially when data is kept for compliance purposes or something you want to maintain for the long term, but you're not sure exactly when it's going to be needed. If it's not customer facing and it doesn't need to be there in milliseconds when they click on a web page or when they try to access the data through another means, then Glacier can be a great fit. You can move terabytes and petabytes of historical data to Glacier. When you need it, you can get it back in minutes or hours, but if you don't need it, you're saving that much on the storage because you're really using a storage class that's optimized for the archive storage. So that's an overview of these different storage classes. Let's look at some different specifics here. The millisecond access that we talked about applies to every storage class all the way over to the Glacier ones. And then with Glacier, you get to minutes or hours of access. So that's the real difference there when customers say, when should I think about Glacier? You'll want to think about workloads that can tolerate waiting that additional latency to get the data back. But for a lot of customers, they'll find that whether it's a matter of object age, or there might be some data that can always fit that profile, and you can just put it to Glacier right away. So that'll give you the flexibility there. The next one we want to look at is kind of the storage footprint, and we use the term resiliency when we think of how we store your data within S3. We're storing it not only across different data centers, but across different availability zones. So for nearly all of our storage classes, your data is going to be stored in 3 or more availability zones. And each of those availability zones may be multiple data centers. So you have to think about how much redundancy is built into that type of system, where we can have multiple failures and your data will still be safe, it will still be accessible. The one exception to this, where you want to think about, well, what data might be recreatable, or what data might be less important if it is lost for whatever reason. That's where you see the additional savings of one zone infrequent access relative to standard infrequent access, where there is about a 20% savings between the two storage classes, but it is stored in a single availability zone. So if anything happens to that single availability zone, your data may not be accessible or it may not be recoverable. So that's where you want to say, is one zone infrequent access worth it, and what storage might be able to fit that type of profile and the kind of less resiliency of that particular storage class. And then you see the prices going across. So Glacier Deep Archive is the one I want to highlight here. That price there, where there are a number of decimal points before you get to any significant digits, it is about $1 per terabyte per month. So that is really inexpensive storage, especially for that archive and large amounts of storage that you might be keeping. Compliance is a theme I'm going to keep coming back to, but if you have requirements to hold on to data for the long term, but you know you're not going to be accessing it, Glacier Deep Archive is something customers are really excited about because of the cost savings. And then down the bottom here are some other considerations. So with standard, what we talked about, the general purpose storage class, really great for any type of workloads. There's no additional data that we've added when we added this slide. But for the other storage classes, there may be retrieval fees, monitoring fees, or minimum object sizes, minimum storage duration. So because these storage classes are optimized for infrequent access, they're optimized for archive storage and storing data for longer periods of time, these are some of the things you want to think about. So when we talked about accessing data about 1 time or less per month, that's where something like the retrieval fee for standard infrequent access or one zone infrequent access comes into play. And having that minimum object size then allows us to optimize the storage class differently, but then also helps you get the right amount of savings. Because when we have a minimum object size of 128 kilobytes, if you're storing something much smaller than that, it'll still be charged at 128 kilobytes, so it may not be a good fit to move to those particular storage classes. Now that we've seen all these different storage class options, I want to talk about how you can move data across these storage classes. Because that initial moment when you put data in Amazon S3, that's not the moment where you're locked in. You have a lot of flexibility to then move to different storage classes over time, and that's a pretty common pattern for customers. I may start in standard, and then after a period of time move it to infrequent access, and then after the first year say, now this data is ready to move to Glacier, because it's not going to be accessed, it's not going to require that millisecond access pattern. So every year, I just want to highlight one of the messages here. Customers save millions of dollars using storage class analysis and lifecycle policies because they're moving data to these lower cost storage classes. So how does that work? And how can you get the information you need to make those decisions about what storage class to use? We'll look at some of those things now. For storage class analysis, this is a portion of the console view that I put up on the screen. And it's really showing you that transition point between when data is classified as frequently accessed and when it's classified as infrequently accessed. And that's really the deciding moment, or that's the moment you're looking for when you look at your storage class analysis output results. So how this feature works is you turn it on. You can turn it on at the bucket level and monitor everything in a bucket, or you could turn it on for a single prefix within that bucket, or all the tag data within a bucket. So it allows you to be more specific on what data you wanted to monitor. After about 30 days, so it looks at that data's access for about a month, maybe a little bit more than a month depending on what it's seeing, and then it gives you this output. So right here you're seeing a classification on the kind of console view here. So from 60 to 90 days, any data that's within that age range, you see that the data retrieval of about a petabyte is actually larger than the data stored, which is 682 terabytes. So because the amount of access and the retrievals are larger, that's where you won't see the savings yet in the infrequent access storage classes because of that retrieval fee. Even though the storage is less, the retrieval fee will mean you'll likely be paying more if you used infrequent access storage. But once that data crosses the 3-month mark and gets that 90 to 180 days category, there's about 400 terabytes of data, but it's very low access. There's still some access. Customers still are trying to access this data. Maybe internal users are still accessing this. But you see the amount of data retrieved is so much smaller than the amount of storage. So then storage class analysis classifies that as infrequently accessed, and it may be a good fit to move to standard infrequent access. Or if your data resiliency requirements are such that one zone infrequent access might be a good fit, you can move it there as well. So we're monitoring the access patterns, giving you a recommendation, and then you're going to take that and build a lifecycle policy. So if you like this number, you say 90 days looks like the clear mark for this particular workload, then build a lifecycle policy and say at 90 days, all the data moves to standard infrequent access. And then you can kind of decide how long should it stay in standard infrequent access. Is that in perpetuity? Does it move to Glacier after that? But this amount of data allows you to make that decision, and it does so in a data-driven way off of historical patterns. So for those familiar with lifecycle policies or those who are new to them, this might be a recap for some. So lifecycle policies can be used to move data across our storage classes, so to tier down to lower cost storage classes, or you can use the same policies to actually expire storage. So we talked about a few examples where you might be moving the data to lower cost storage classes, but you might say after 5 years, I actually want to just delete all the data that meets a certain criteria. So you can use lifecycle policies for that as well. The storage class analysis results will guide your writing of a lifecycle policy, or you may know enough about an application that you can just write that policy yourself. And then on the last part here, something that we talked about before, but you can filter these rules. So it might not make sense to write something for an entire bucket. You could filter that down to an individual prefix or everything tagged with a certain value. So let's walk through some examples. Here's one where the data starts in standard, and then after 60 days, it's all moving to standard infrequent access. And then after 180 days from the creation time from when it was first put, then it moves to Glacier. So it's a pretty common pattern for customers where you want to maintain that millisecond access for some period of time, but then after a half a year here, it's fine moving to Glacier, and you're saving that much on the storage. In this next example, start everything in intelligent tiering. We're going to talk about that storage class in more detail in a second, but start in intelligent tiering where it's already moving between a frequent and an infrequent tier, but I only need that for about a half a year, and then I'm going to move it to Glacier. And then in this example, we add that final step where it's still in intelligent tiering, moves to Glacier, and now Glacier Deep Archive, where we saw at $1 per terabyte per month, it may be a great fit for data for the long term. So that's something you may want to consider. And you may already have lifecycle policies that are moving data to Glacier that you may think, well, maybe a half a year or a year after that, maybe I should just move it to Glacier Deep Archive for the rest of its life. So that might be something where you have existing rules today that you say, hey, it does make sense to add a Glacier Deep Archive step at the end. So now let's talk about one of our newest storage classes, which is intelligent tiering. And we'll first kind of talk about the basics of how it works, and then go into where this might be a really good fit for you to get started with. So here you see how data comes into intelligent tiering, and it all starts in the frequent access tier. So all data that goes to intelligent tiering, you can directly put it there, or you can use a lifecycle policy to move to intelligent tiering. It will all start in the frequent access tier. And then after 30 days, we're looking at the access patterns on that object. If that individual object is not accessed for 30 days, then it moves to the infrequent tier. And the way to think about these tiers is the frequent tier is priced the same as S3 standard, and the infrequent tier is priced the same as standard infrequent access. So you're getting the 3 or more availability zone resiliency of those storage classes. After 30 days, if the object's not touched, it moves to the infrequent tier. If it's accessed again, then it moves back to the frequent tier, and then 30 days later, it may move back down again. So it's looking at each individual object and making that decision. So you want to think about how kind of heterogeneous your objects may be, and it may be that 10 objects are read very frequently, and they're read all the time, and it kind of masks the overall numbers, where you see a lot of access in a particular bucket, but it may be a very small subset of the data. Well, we'll just keep those objects in the frequent tier, but everything else that's never been touched moves to the infrequent tier, and you see what's typically about 40% savings, depending on the object size and depending on how much data moves. But you're getting that savings between the frequent and infrequent tier. So let's go into a little more detail on this next slide. So it's automatically moving them, and it's moving them on the object level. It's monitoring the access patterns over time. So once data is moved to this storage class, it really starts to make that optimization and really starts to make those decisions right away. It will be in the frequent tier for the first 30 days, but those accesses that happen over that period of time will affect the timing of subsequent transitions. There's no performance impact. So I'll come back to this theme. This is a question we get from a lot of customers, like, should I be worried about my internal users, external users of my storage? Are they going to notice that I'm now using intelligent tiering and saving more on the storage? No performance impact. They're still going to get millisecond access. They're still going to see the same performance they were before. And there's no operational overhead for you. So all of the steps we talked about where storage class analysis, taking that data, building a lifecycle policy, that is some manual work. It's not a lot. It's pretty convenient. The information is readily available. But as things change over time, if you're in intelligent tiering, you've just offloaded all that work. You don't have to think about how it might change over time. Millisecond access, more than 3 AZs. And then the monitoring fee per object is just something I'll mention. If you have a lot of small objects in kind of the kilobyte range, that monitoring fee, which is per object, because we are looking at the access patterns over time, when the objects are smaller, that monitoring fee becomes a larger kind of percentage of your bill and what you'd be paying for in storage. When your objects are larger in the megabyte, gigabyte range, that monitoring fee is so small that it really won't affect the savings that you're achieving between those two tiers. So it's something to think about, and when we look at a few examples, you'll see how that guides some different customers' decisions about whether to use intelligent tiering or not. So there's some few ideal use cases, and this is kind of big picture, but may help you think about what might be a good fit. So first is big data lakes, where you may have a lot of different applications trying to access the data. You've worked hard to aggregate a lot of data into the data lake, but it's hard to map to exactly what teams, what applications are reading that data, and what that access pattern is going to look like. Is it going to be very discrete moments over time, or are you going to get pretty heavy reads on a consistent basis? And how do you think about an overall bucket worth of data where there may be a lot of access on 10% of that data, but almost everything else is never touched? So by having an intelligent tiering storage class where we're making object-by-object decisions, it's something where what could have been a complex access pattern over an entire data lake now becomes something you can just hand off and do that at the object level. For enterprises, it may be about the amount of teams that are accessing data. So with a lot of different teams using the data, with a lot of different teams using the same place to store the data, it can be hard to map to and understand exactly what the data patterns are going to look like. So intelligent tiering may be a really good fit there as well. And for startups, we'll just highlight where startups want to put their investment and their time into growing their business, and managing storage classes may not be the best place to spend their time. So using something like intelligent tiering is a way to offload that work, but also see the savings that then can be fed back into the business. So here's the first pattern I'll put up on the screen while I take a quick sip of water. But we'll talk through these examples and why a certain storage class might be a good choice. So here, we're using the same colors we did before in the storage class analysis, where you see the blue is the storage growing over time. So it's pretty steady growth in the storage. But the access remains kind of high relative to that storage. So there's a lot more access and data retrieved relative to the data stored. So it's frequently accessed. It's more than 100% of the storage being retrieved over time. This could be something like origin storage for a CDN. It could be something like a big data analytics workload where those queries are running all the time. And here you may see a case where S3 standard's a good fit because you're avoiding those retrieval fees. Or if you find that it's maybe a small subset of the objects being accessed a lot and a lot of the objects are colder, then intelligent tiering will help you achieve that savings because it will be moving objects to the infrequent tier when they're not being accessed. So that's our first example, kind of a basic one. Here we're seeing more of a predictable pattern where the storage is still growing over time, but a lot of access right up front actually really tails off over time. And it's somewhat predictable where you see these spikes, but you see how they kind of drop off over time. So this could be something like kind of assets stored for gaming workloads. So you may have history of particular users and see that drop off over time because it's relevant right away, but after time it's more of a historical analysis. It's less likely you're going to go back to that. Another one might be user-generated content. So you can think of something like uploading photos or videos from a recent vacation where there might be a lot of access as you share that right away, but then it's going to drop off over time, and it's kind of that nostalgia moment where you go back and read it, but you're not going to see that as frequently over time. So here, lifecycle policies are a good fit because you are seeing a predictable drop-off over time. So you could use standard then lifecycle policies to transition it over time. You could put it directly to intelligent tiering and achieve that savings as the access patterns die off. And then towards the tail end here, where it's less likely that the data is going to be touched at all, then Glacier may be a really good fit. So once again, kind of a basic scenario and something that a lot of folks will see in their data if you use something like storage class analysis. This is a pretty common pattern. Next, we'll look at data with changing access patterns. So once again, the storage is fairly steady, maybe a slight growth over time. But now I have these unpredictable spikes, it looks like. There may be some periodicity here, and you may get some idea of that. But if these are unpredictable and you're not sure when they're going to happen, then you absolutely want to look at something like intelligent tiering. This is larger storage, so it looks like geospatial data. So this might be satellite imagery. This might be something like autonomous vehicle data. And then there's large amounts of analytics that might look at that data over a period of time. And when you're using intelligent tiering with no retrieval fee and the ability to move to that infrequent tier in these pockets in between where the data is not accessed, maybe a really good fit for intelligent tiering. On this last one, we've got two scenarios where you don't know as much information. So this may reflect a scenario where a lot of people are in, where something's newer or it's just hard to gather the information about data's usage. So the one up top, you don't know a lot about the workload, but you know the objects are larger, so they're kind of in the megabyte range. And then the storage duration is long, so we're going to keep this data for months or years. That sounds like a good fit for intelligent tiering, where you could start an intelligent tiering, and even though you don't know a lot about the workload, the access patterns over time will help intelligent tiering to move that to the infrequent tier and save some money. And then the second one, once again, an unknown workload, but we're seeing a mix of object sizes. So there are a mix of those, and it's really uncertain as to where those really clump around and what the average might look like. And then there are a lot of short-lived objects. So if things are only living for days, hours, you have a lot of things on that shorter end of the spectrum. With those minimum storage durations on the infrequent tiers, intelligent tiering and Glacier, you may just want to start with standard here. And then as you gain more information over time, intelligent tiering might prove to be a fit in the longer term, but you really want to learn more before you might try that storage class out. So that's a few different patterns. Hope that helped you guys kind of think through how the different storage classes may come in handy. The next topic we'll talk about is another recently launched product, so right from the end of April this year, so customers are really ramping up on it now, Amazon S3 batch operations. And the headline here is you're going to save time on developing tools to do batch operations, so anything that's large scale where you're operating on thousands, millions, billions of objects, and you just want to hand off that work and you don't want to write your own script or tool that can handle that scale, you're going to save a lot of development time. And then we'll see some of the conveniences built into this feature where somebody who's doing this themselves and kind of doing it manually, there may not be the monitoring tools and the way to really see, well, is this resilient? Is this going to keep running through any kind of errors I run into? Or am I going to keep having to rerun this thing? And then how do I get progress visibility so I can share with others in my organization, like, here's how the work is progressing, and here's when I think it's going to be done. You've got those tools here, and it's built in, so it's going to be that much more convenient for you. And it's something where you can take this large amount of objects, hand it off to S3, and it's really one request to kick off an entire job. So even though the scale may be large, it's really very little work on your part to kick that off. So this is the kind of most basic way we can look over it. You're going to develop a list of the objects. So you can use something like our inventory feature, which already gives you lists of contents in a particular bucket. So you can use that to get your list of objects, or if you have a secondary database or other metadata store about your storage in Amazon S3, you can use that to generate a list of objects. Once you have that list, then it's just a matter of telling S3 batch operations what operation you want to perform. Copy is one of the basic examples there. So if you want to copy the data to another bucket, another account altogether, and you want to just transfer data over, then that could be one of the simple operations you can kick off with this. And then the progress visibility and some of the other tools you have means that you can always check in on the dashboard. You can use the APIs, SDK, to actually check in and see how a particular job's progressing. And you have other tools to then make changes about what job's more important than which, and which one you want to kick off and kind of take precedence over the others. So this slide will then go into more detail about kind of how this works step by step. So it can be your own CSV list that you create depending on the scale of the objects and what information you have. You could even start with the S3 inventory report, which is something where you can generate a list of everything in a bucket, or you could say, I only care about what's in this particular prefix. And we'll talk through some scenarios later on, but that list of everything in a bucket might not be exactly what you're looking for. You might see that giant list and say, well, I don't want to operate on all billion objects. There's really like 25 million objects here that are really relevant to me. Use a tool like Athena. Use something like S3 Select, and use that to filter down the list based on the criteria you're looking for, and then you'll be able to have a more targeted list and kick off that job at batch operations, operate on only what you want to operate on, and then it's going to be done that much quicker when you're able to filter down the set of objects. So selecting the set of objects, there are 4 native S3 operations. So copy, tagging objects, changing the access control list on a particular object, or restoring objects from Glacier. So all those use cases we talked about before where you're moving data to Glacier, there may be moments where you're moving hundreds of thousands or millions of objects back to S3 because you either need to send them off to a third party or you want to do analysis of your Glacier objects. This is a great way to get that data back in bulk and kick off all those restores at once. And then the last one you see here listed on the list really opens up a whole lot of possibilities, and that's running AWS Lambda functions. So for each object that you've listed in your manifest, you can say, OK, I want you to read that object, look for particular properties, or perform machine learning on a particular object. Then I want you to send the results here, and I want you to also put those results into a file where I can look at after the batch operations job. The demo that we walk through will be AWS Lambda function using recognition. So that's image recognition on the objects. Basically, think of the scenario where you have a whole lot of static images in S3, but you're not quite sure what the mix of those objects is. Using batch operations to go through that entire list, run recognition, and then start to put together pieces of metadata on what you have stored in S3. Now you've taken what was kind of static storage. You weren't quite sure how you were going to use it. You weren't sure how you were going to share it with your end users. And now you've got something like a searchable catalog. You've got a way for users to query it. You've got ways for yourselves to make recommendations about what they might be interested in based on the properties of something. So that's one case for Lambda. We've had customers really interested in transforming the kind of data formats of particular pieces of data. So something where you want to unify a data lake into one particular format, a Lambda function could help you do that. Lambda functions for making thumbnails, running the machine learning workloads. A lot of different flexibility with what you can do with Lambda. And then you could have your own custom code that's scanning objects and looking for particular characteristics in an object. You could absolutely do that as well with batch operations plus Lambda. And then you have the ability to view progress. So at an overall level, you're viewing how many operations were successful, how many were failed, what's the percentage progress we've made along the way. Job notifications allow you to use CloudWatch events to say, well, I want to know when this job starts. I want to know when it goes active, when it actually starts executing, and then I want a notification when it's complete. So it's something where you're not checking in, but you're getting that push notification to let you know when a particular job has reached a certain milestone. And then the completion report is something you can customize. So when you request a completion report, you can say, I want a list of everything batch operations did. It's a CSV that we're just going to list out everything we did. And it could be everything successful and failed, basically all tasks. Or you could filter that down and say, I only want a list of all the failures. And then it shows you the error, so you can go back and say, OK, if I fix this issue, now I'm going to go back and rerun this set of objects from this failure report. And now I know that everything is complete, and I can move on with my day. I was able to check that off my box. And now we can move on with whatever else we're doing in our business. So that completion report gives you a one-stop shop for everything the batch operations job did. The S3 inventory report, this is a quick recap, or for folks that aren't familiar with it. So it can be a list of everything in a bucket or a prefix. Customers use this for auditing, analytics. So that filtering we talked about earlier, you can also use it to answer questions like, hey, I know there's a lot of data stored in this bucket and it was stored over the last 5 years. I turned on default encryption maybe somewhere in the middle of that. So I know I have a lot of unencrypted storage, and then I started encrypting the more recent objects. I want to answer the question of how much is unencrypted, how much is encrypted. That's something where this inventory report plus Athena could just give you a quick way to access that information based on some of the columns that are there. So if you want to know more about the storage classes of your objects, you have that filter criteria in here. Creation date, encryption status, replication status, object size. So you have a number of different criteria. You also have the strings of the names of the object and the bucket they're in, so you can use those to filter them as well. We'll talk through one example towards the end of these slides. And here you have the overall console view. And don't spend a lot of time on it now. We'll kind of walk through this when we go through the demo. But you have all the information about a particular job. You have information about when it was created. You can customize the name of a job, basically add a description, so you know what jobs map to what teams or why a particular job was kicked off. Especially if that job doesn't run to completion, you want to say, like, is it more important that I go back and fix this job or this job? That's something that might be helpful to put something in that character right there. Then you see the job state, how large the job is. You see the progress, and then you're seeing the priority number. Priority I'll address here briefly. When you have a number of different jobs running, that priority number is a way where you say, well, this job I just started is kind of paused because it's behind all these other jobs in the queue. That's actually the most important thing. I want this kicked off right now. Change that priority value. The system will look at it. They'll see a higher priority, and that job will activate while another job pauses. So there is a certain number of jobs you can run at once, and that's really to ensure you're getting enough throughput on the jobs that are running. So then priority is your way of shifting those around and changing the precedence as needed. So I just want to highlight here, S3 batch operations, it's really a managed solution. It's doing the automatic retries, so if for any reason an operation doesn't run right away and it's something we can retry, we'll just retry that within batch operations. So we want to get to 100% completion, and we'll work through things like any transient failures. You'll see the progress along the way. You have the management controls to cancel jobs to update the priority levels over time. And then you have those notifications when jobs transition to different states. The auditing refers to that completion report and the information you're going to get there. And I think the overall message here is, if your company's already doing something where you have a tool and you're doing work over time to maintain it, if you can hand that work off to S3 batch operations, then that's one less thing your company's doing. And now you've got a managed tool where you say, all I really want to focus on is generating the right list. And then I can hand that off to batch operations on a daily basis, every hour, whatever the right periodicity is. But it's something where it takes away that kind of execution phase and managing that work and actually managing the individual tasks. The next thing I'll highlight is kind of if you've had that job sitting around, like the encryption case we talked about, where there's a lot of unencrypted data and nobody's ever gotten around to going back and encrypting it, it's something you want to do for compliance purposes. Now you've got a tool where in a few steps, and I can talk to anyone who wants to talk about it afterwards, but something like Athena and S3 Select ramping up on them, simple query, filter down, kick off a batch operations job, and now it's something where you can go to somebody and probably within 15 or 30 minutes of work, you now kicked off a job to encrypt all your existing objects. And that feels really good when you can get something like that done in a very short period of time. So now I want to introduce and talk about the demo that we're going to look at, and then we'll walk through it step by step. So the demo overview, as we talked about, it's batch operations used with AWS Lambda. There are images stored in an S3 bucket. We have a fairly small number here because I just want to show you guys how it works. It's about 800 images. And these are things just crawled from the web, so they're images of space, satellites, rockets. It's really from a NASA database. So you'll see that in the categorizations and the different metadata and labels that we pull from these particular images. We're going to invoke the Lambda function that's then going to use recognition. And recognition is our machine learning service that does image recognition. So it's going to take those labels, send them to an Elasticsearch database, Elasticsearch service, that then the Kibana dashboard is actually looking at that Elasticsearch labels. So as the labels are made by recognition, they go to Elasticsearch, and then Kibana updates, and we'll see the dashboard change over time as those results start to make their way through the pipeline. Here's a quick visual of what that looks like. I've had a lot of questions from customers about kind of what lives inside the Lambda function for this particular job. So batch operations create the job, specify this Lambda function, but then within that Lambda, an individual object gets passed from the manifest, so that will be a particular image. Recognition goes to the bucket, gets that image, reads it, looks at the particular image, generates those labels, and then sends them to Elasticsearch as part of the Lambda function. So that's all happening within Lambda, and then the dashboard is something where I just open it separately, and then we see the results change once information starts to flow to Elasticsearch. So with that, we'll switch over to the demo view, and then we can see how this looks in action. Excellent. So we're back to that overall console view that we talked about before. And one of the cool things you can do through the console is basically I have this job. So this is a case where I ran this job earlier. So I'm going to use what's called a clone feature, where we're going to take all the properties from an existing job and just run that job again. In this case, we're going to make no changes. We may make some minor tweaks along the way for priority, for example. But where you can see this being valuable in your own business is, let's say that job to encrypt your existing objects. If you get that up and running for one bucket, then running it on different buckets is just a matter of changing the list of objects. Every other property is going to be the same along the way. So then you can click Clone Job, update the list of objects, and then you're just going through this console view and saying, OK, it's basically the same job. Click, 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 kick off a job to then encrypt the objects in a different bucket. So you could do that here in the console view depending on how many you have. Or when you're doing this programmatically, you can once again see how nearly all the parameters will be the same, and it's just a matter of shifting the list of objects, switching the list of objects when you're doing something similar. So let's go ahead and click Clone Job. We're here, and we're in Northern Virginia for this particular job. So the job location and looking at that region, it's really just about matching to what is the region where the objects are located. So where is the bucket located? Where's the storage? And then for copy jobs, you want to put in the destination region for a particular job. So if it's within the same region, that's pretty self-explanatory. But when you're doing cross-region jobs, you'll create the job in the destination location. Here we're using an S3 inventory report. So that's exactly what we talked about before. I didn't want to create a list of these objects. Granted, the scale is very small. But once you get to a larger scale, if you don't want to go through a list and creating your own kind of set of the objects and building your own CSV, just generate an S3 inventory report and then get started with selecting it here. So we're going to click Next. On this step, you see how you can choose the different types of operations at the top. Fairly simple to go through them, and they're all pretty self-explanatory parameters. We'll look at some examples later on. In this one, I just want to use a Lambda function. It's called the NASA demo, and I'm going to use the latest version. So once again, very simple to specify. It's a Lambda function. Here's the one we're looking for. Next step. And then here, so I'll just add Summit to the end to make it even more clear what we're doing today. Priority. So the way to think about priority is the numbers you choose for priority are all relative to the other jobs you created. So you can choose quite a few numbers on the number scale here. I use numbers typically between about 1 and 25. And that gives me enough room that when I have different jobs running, I can say, well, 15 is a more important job. Most of my jobs will just default to priority 10. But when you start thinking about this and growing it at scale at your own company, you can kind of set those different thresholds. And when a job's of a certain type, maybe it always gets set at priority 50. And when jobs are of a lower value, it's kind of something just running in the background, set them at priority 5. So it's really just relative to one another. You could just use sequential numbers to do that as well. But I try to leave some room in between if I kick off a number of different jobs. In this case, I'm going to generate a completion report, and I'm going to do all tasks. That's kind of influenced by the fact that this is a very small job. So with about 800 images, I'm only going to have 800 lines in a CSV. Quite easy to open that up, just do it in Excel. But when you start getting to billions of objects in a particular job, you may not want to sift through all of the successful tasks, or it may not even be useful that you keep a record of all of those. So there you might want to select, I only want the failed tasks. And likely that's going to be a much smaller percentage. We've seen customers run larger jobs, and in some cases, if something like the permissions aren't set correctly, a job may fail right away. So we may run 5,000 tasks. If they all fail, there's a short circuit feature. So it'll just it'll basically fail the job at that point, and you can go back and troubleshoot based on, okay, there were 5,000 failures, here's the issue, correct that, run the job. But for something like running across 5 billion objects, let's say 100 of those objects were deleted by another application while the job was running. That's a reason where you'd see a failure. You'd go into your completion report and say, okay, the object was not found. You could do some additional diving into the logs, but that's a pretty clear case of why it failed. Something like permissions on specific objects, something you can go back to, correct, and then kick the job off. So when the job gets larger, it may make sense to just look at the failed tests only. I'm just specifying where to store that completion report. And then here is, I'll open this up briefly and talk about it. This isn't really a security session focused, but you'll be able to see how this works and kind of talk through it. So batch operations assumes an IAM role to actually perform the work on your behalf. So it's acting within your account and performing the work. So then you can be very clear cut on what you want batch operations to be able to do and not be able to do. For this one, I need the permission to invoke a Lambda function. So you see that up on the screen. And then I want permission to, in this section, you're looking at reading the manifest. So I have an S3 inventory report, and I need batch operations to be able to read that to know what to operate on. So this section of the permissions is about reading the manifest. And then this section of the permissions down here is about writing the completion report. So there's just a few steps here where, depending on what you want to do for a particular job, you would just have to build a role that includes those permissions. We've got examples here in the console. We've also got some in the documentation to help you ramp up and get started. And for those familiar with IAM roles, the other thing I'll highlight is the trust policy. So this is guidance on who can assume a role and who can perform work on my behalf. In this case, S3 batch operations needs the ability to assume this role. So this is something where when you're plugging in a trust policy, you can just cut and paste this into your IAM role and get up and running that way. So everything here is already specified. I've run this job before, so I have an IAM role already created. And then here is a review screen. And the one thing I'll highlight here is not in detail, but looking down the screen, one thing we don't know at this phase is how many objects are in a particular job. So I've specified a manifest. I've said, go read this object in S3 and operate on everything. But S3 batch operations doesn't know anything about the scale of this job. And this is something I want to encourage everyone to when you start to test this and when you start to run it in production. If you're doing one-off jobs through the console, or even if you're doing something programmatically, there's the ability to set what's called kind of an awaiting confirmation step. And when you do this programmatically, you can set whether that's required or not. And when you're doing it through the console, it's always required. But what's happening is S3 batch operations reads that list. In this case, the number will be 799 objects. But I know that. That's my expectation going in. I then look at the job later on. S3 batch operations has read the job. It's at this awaiting confirmation step. I'm going to check all these parameters again for the job, but then I see that number 799. That matches what I'm looking for. I'm going to click Run Job, and then we'll kick it off. But you can see yourselves doing testing here. And you say, well, I'm just going to test this on about 100 objects. If you get to that screen where you're confirming the job, and the job says 150,000 objects, well then either the wrong object was selected or the wrong manifest, like something went wrong where you said, I was going to do a test on 100. I see this large number. I want to slow down at that point. Cancel that job, go back, kind of figure out what went wrong, and then go back and kick off the job. So that's the reason we put that step in place, was really one more check to make sure the parameters look correct and make sure the object looks correct before you kick it off. So here we'll go ahead and clone this job. Takes us back to this confirmation state, kind of the overall dashboard view. And because we have such a small manifest, it's going to go ahead and run very quickly. So we now have a job at the awaiting your confirmation step. And here we see that 799 is now populated. And I could scroll down here. I mean, jobs of various sizes will add up over time. I've got jobs in the millions. We've run this demo a few times to test it and everything. But when jobs get to 50 million, 100 million, and so forth, it may take a little bit longer to read that manifest. But that's the goal, is we're looking for errors and issues in kind of the key names themselves. But we're also giving you a count. So it helps you to understand what's going to be kicked off next. And then, like any good kind of magician or any demo, I'm going to show you that the dashboard is empty before we go there, because otherwise you wouldn't buy it at all. So we've got a dashboard here that's updating every 5 seconds. It's empty right now. We've just got a few things we're going to look at in this dashboard once those labels start populating. But I want to show you this before we go ahead and kick off the job. So here's that DC Summit job we created. Confirm and run. As I pointed out, you're really looking through the same parameters as you scroll down here, just making sure everything was correct and everything is as you expected. That object's listed in the manifest is now populated with 799. And then we are going to run this job. So we successfully received confirmation for the job. And now we'll sit here on the dashboard view, and we'll see as the individual Lambda functions are invoked for each object in the manifest, we're going to see this dashboard populate. And one thing I'll highlight at this phase is this number right here that's 74 right now is bucket keys. So we ran on 799 objects, but within this Lambda function, we're looking at a pretty high confidence interval where we said anything where we're not 97% or more confident in a particular label, just throw it out. I don't want to see it in this dashboard view. I don't want to see those labels get passed through. So they actually get written to the final report, so you can go back and look at that completion report and say, what went wrong with a particular image? Why didn't I get a particular label for it? You can see those confidence intervals. That's something where we're using the completion report to store a lot of metadata. And then here you're seeing a few different things. So these are the different labels that are identified for those images. So 400 images, 1,400 labels. There's multiple labels per image, as you might expect. And then here I talked about where some of these images are coming from. So human and person are pretty popular, but rocket, transportation, some of the things about crowds and kind of larger shots that you might see. And then outdoors, night, nature, things down here as far as building towers. So you could picture a launch pad might be in that particular image. So that's just giving you an idea of some of the labels you'd get from recognition. And then over here in this bottom left is looking at some of our most popular labels. So there's enough people, kind of astronauts or spectators in this particular images where that's popping up pretty high, but then outdoors, astronomy, outer space. This is a pretty kind of homogeneous group of images where it's kind of the space industry, but you could do this for user-generated content where you might have a lot of user-generated content that's saved, but you want to say, how can I make this more interesting for my end users? How can I make product recommendations? How can I do other things? Using batch operations is a way where you can access a whole lot of images in a hurry, kick off machine learning, and then allow batch operations to do the work rather than you thinking of that phase. You can think more about what do I do with the information once I have it. And this particular Lambda was really built to give you some visualization of how this feature works, but you can do so many things in Lambda. I'd love to talk to folks afterwards if you have more questions about this feature. So we've got that there. The job now shifts to, you'll see it walk through the completing, and then now it's in the complete phase. So that means if I went to go look for that completion report, I could go open that up now and actually see what ran on a particular job. So with that, we'll jump back into the slides and kind of walk through some other examples briefly. Excellent. So walk through the demo. Hope you all enjoyed kind of seeing the feature in action. And then here are some other common uses for batch operations that I hinted at earlier. So encrypting existing objects is a case where you'll just copy objects to the same bucket. So because the key name will just overwrite existing objects, there's differences on whether your objects are versioned or not. But this is a way that we'd recommend you go back and say, well, I have all the data I want. I just want to encrypt it. You're doing a copy operation. You're specifying encryption. So in this case, I'll use the server-side encryption with the S3 keys and just write those objects back to themselves. Because I don't want to do that with every object unnecessarily, I can go ahead and use S3 select or Athena to take my inventory report, say anything that's not encrypted, basically look for that field and do that filtering, and then run on only the unencrypted objects and perform this work in batch operations. Then I could go back 2 days later, look at an inventory report, run that same query, and see that now all my objects are encrypted. So you could do multiple steps here and kind of go back and verify, but it's an easy way to get up and running and use those filtering tools to narrow down your criteria. Then here we're looking at copying objects to a new location. So I just want to emphasize here the flexibility that you can copy within regions, or across accounts. There are a number of customers, I like the phrase kind of meet me in the cloud, which I've heard a few times, but if you've got partners you work with and you just want to copy data over to their bucket, batch operations is a great way to do that because you have all the ability to set an IAM role that's going to be able to work across those accounts. And then you could even have a role in their account do the copy, so then they have ownership of those objects when it gets to their bucket. So that's something you might want to think about, and we have some cross-account examples in our documentation. Here, when you're restoring objects from Glacier, it's so simple that I wanted to show you this screen. It's just specifying how long you want that copy to restore from Glacier. It's a temporary copy of the object. So the object data itself is still stored in Glacier, and now you also have a temporary copy in S3. So you're really just saying how many days do I want that temporary copy available, where you're paying for S3 storage for that data while you're using it more actively, whether to download it, copy it, perform some analytics on it. And then you can use the Glacier restore notifications to actually understand when are these objects available in S3. What batch operations does is initiate the restore, and then once the object lands in S3 and you can actually go ahead and download it or use that object, you can use notifications to track that progress as well. So those are just a few examples. Here, we'll just go over what we talked about. So we talked about application requirements, understanding how your data is used. The organization of your data will then influence how lifecycle policies or some other tools might work for you. Batch operations, great for common tasks, really about simplicity. Intelligent tiering for that automated cost savings at the object level. So I'm glad we were able to review those. And then please complete your session survey. So thank you for doing that. And thank you all for coming today. I'll appreciate it.